Well, hi, folks. My name is Patrick Koehn. I am the new Hermes program scientist at headquarters. Here to give you an update. Let's go to the next slide. I want to make sure I acknowledge the teams. These are the instrumentation teams as well as the program managers, mostly at Goddard there. And they all contributed to this talk, but a big shout out to Bill Patterson for accumulating these slides and putting them together. I appreciate it. Next slide, please. All right. I am going to kill my camera because I have some bandwidth issues. There we go. All right, so Hermes is one of two external payloads that are going to launch with the initial gateway modules. There's the power and propulsion element, or PPE, as you see indicated there, as well as the habitation and logistics outpost, or HALO. The other external payload is the ESA radiation sensor array, or ERSA. Now, ERSA will attach to the PPE, whereas Hermes will be mounted on the HALO itself. Hermes and ERSA have complementary and overlapping objectives, and the science teams are going to be working together. Coordination for that is being provided by agreements developed through Gateway's International Radiation and Space Weather Working Group with representatives from ESA, JAXA, and CSA. The third payload, the Internal Dosimeter Array, or IDA, with contributions from JAXA and ESA, will be inside the HALO module. Next slide. All right, so the instruments are well underway. We've got MERIT, which is the miniaturized electron-proton telescope. It's actually, you can't see where I'm pointing on the screen. That's the one on the lower right. There's also SPAN-I, which is a solar probe analyzer looking at ions. EEA, the electrostatic analyzer. That one's pretty self-explanatory. There's also Nemesis, which is the noise eliminating magnetometer in a small integrated system. It's 3 magnetometers. It's got error correction. There's no boom or algorithms. There are algorithms for error correction through the comparison of signals. Now, just for comparison, Themis has a magnetometer, has an EEA-like instrument, a SPAN-like instrument, but doesn't have mass separation. There's also a superthermal particle instrument that covers energies between those of the EEA/SPAN as well as MERIT. All right, next slide. So here we see a diagram, rough diagram of one plane of the area of interest. This is just the moon orbiting the Earth, and of course, since Gateway will be orbiting the moon, the instruments will be spending about 80% of their time out in the solar wind, where we will be addressing the first of 3 goals. It's determine the mechanisms of solar wind mass and energy transport. And then the remaining 20% of the time, the instrument's going to be in the Earth's magnetotail, where we'll cover our second goal, which is to characterize the energy, topology, and ion composition in the deep magnetotail. And goal C is more pragmatic. We expect some complications in measuring the space environment from complex non-ideal from the platform. We expect that the Hermes experience will be enabling for future exploration missions. Next slide. All right, so Hermes on Gateway is going to be leveraging 3 factors to provide unique contributions to science. It's adding measurement capabilities to the Small Heliospheric System Observatory, or HSO constellation, observing cislunar space. That's both MERIT and SPAN-I. Gateway's polar lunar orbit takes Hermes out of the equatorial plane. It actually, its orbit around the moon is perpendicular to the equatorial plane, more or less. And instruments in common with other HSO missions are going to allow inter-spacecraft comparison. Essentially, instrument-wise, there's some similar capabilities, and with Gateway's polar orbit, I already said that. My apologies. Next slide, please. All right, so we've got four Hermes instrument teams. They have a primary responsibility for delivering and operating the space instruments, as well as the science data through level 2 to the public data archives. We'll also need, or they will also be addressing Hermes defined science objectives. There are also 6 competitively selected Hermes interdisciplinary science teams. They're going to be working with the instrumentation teams that will develop advanced data products and address Hermes defined science objectives. They'll also address additional objectives defined by the IDS team. Now, the HIDS teams do include some international partners on a no exchange of funds basis. Finally, there are collaborations with complementary payloads and science teams from ESA and JAXA that are enabled by multilateral agency agreements. That would be both URSA and IDA. Last slide. Okay, so essentially Hermes is a mission of opportunity made possible by the Gateway. The launch is now set to be no earlier than October 2025. The transfer to lunar orbit will utilize the PPE's ion drive and take about 1 year. Phase E science begins once the Gateway is in lunar orbit, although some opportunistic observations in the radiation belt may be acquired during transit. The science objectives address both the interplanetary medium and the Earth's magnetosphere. The Gateway's polar lunar orbit will be used to scientific advantage in working with other Helio missions closer to the equatorial plane. And it's important to note that Hermes is expected to serve as a pathfinder for future missions of exploration. At the moment, our space weather assets are mostly deployed along the Earth-Sun line, but future deep space missions with crew likely would benefit from in situ space weather measurements to provide alerts and improve the fidelity of predictions. And that's what I've got. Thanks for your attention.